So we'll now work through just part 2 of section 2.5, multiple representations of lines. We have some different word descriptions here. We have a graph, we have a table, we have an equation that we're going to state. We're going to work through all these different representations of lines. The linear function g of x has a rate of change of -7 and an initial value of 1. Well, the nice thing with an initial value tells us what? That's the value that the function produces when x is equal to 0. I know that 0, 1 is a point. I also know that I have a rate of change of -7. That's the slope of the line. So I can already go over to slope-intercept form. Y equals, hey, -7. -7x plus 1. I have the equation, rate of change, -7. Remember, that's the slope of a line. When you have a linear function with that rate of change, it's always the same rate of change. Initial value of 1 tells me what? The value of b in y equals mx plus b. I know that b equals 1. I know that m equals -7, and there's my equation. I can build a quick table. Again, I have my y-intercept location, 0, 1. Tell you what, let's just make x equal to 1. I know what? I have a change of -7. How far down would I have to go? Over 1 down 7. Well, there's my over 1. I went from 0 to 1 along the x-axis. I went down 7. I'm going to be at 1, -6. Let's find that. 1, 2, 3, 4, 5, 6. And there goes my line. And my line equation is built. That's it. Okay, here's a new one here. I have a table this time. Well, what can I do? I see a value of 0. I see a -1. I know this is a linear function with an initial value. Initial value is equal to 1. And by the way, can I look at this? Yeah, it looks like as I increment by 1, I'm going down by, looks like I'm going down by 3 each time. So I could fill out a little bit more of this table. 1, -4, 2, -7. And if I look close enough, that's a constant rate of change. Every time my x-coordinate increases by 1, my y-coordinate goes down by 3. I have a slope equal -3. So what do I have? I have a linear function. Oh, the pen's given out, sorry about that. Linear function with rate of change equal -3 and an initial value of 1. I have a whole bunch of points here. There's my 0, -1. I have -1, -4. Go down 3 more. And I know again, just keep going, 1, 2, 3. I can go ahead and do the same thing again. Draw my line. Make sure I give it good representation with arrows in both directions. What's this equation? Y equals -3x minus 1. Initial value of -1. If I spoke before, I said initial value 1. I apologize there. It's an initial value of -1. My fault there. So just make sure you correct that little verbal mistake that I made at the beginning as we were working through this. So that's how I can work with tabular form or a description of a line, build a graph, build an equation, build a table if I need to. Let's do some additional work with finding equations of lines. And remember, we're going to work with our different representations that we might have, whether that be slope-intercept form, standard form, point-slope form. We'll talk our way through some of these. Find the equation of a line that has a slope of 3 and passes through the point 3, -7. Sounds like we got a slope, sounds like we got a point. I would think that point-slope form might not be the worst thing to do here. We know what our point-slope form looks like. Y minus y1 equals m times x minus x1. I know that my m is equal to 3, so I'm good there. I know that what? My x1 is -3, my y1 is -7. So, y minus y1 is going to look like y plus 7 equals what? 3 times x minus 3, x plus 3. Y plus 7 equals 3 times x plus 3. That's a good point-slope recommendation or format for this line. Could we go to standard form where we put what? X and Y on the same side? Sure, let's do it real quick. So this is, I'm going to write PS for point slope. Now I'm going to do standard. Well, I got y plus 7 equals 3x plus 3. Let's expand real quick. Y plus 7 equals 3x plus 9. Just distribute to 3. In standard form, what do? You get your y's and x's on the same side. I'm going to say y minus 3x, bring the 3x over this way, equals what? 9 minus 7. Y minus 3x equals 2. And by the way, could I also build slope-intercept form? Sure. For slope-intercept form, what do you need to do? Just take standard form, solve for y. Y equals, I don't want that negative 3x over here, I want it on the other side. Y equals 3x plus 2. And away I go, and we have everything built that we need. 3 different interpretations, 3 different line equation forms, all satisfying a line with a slope of 3 that passes through the point, -3, -7. All right, let's keep rolling. Find the equation of a line that is parallel to the line x plus y equals 2 and passes through the point -2, 5. We're going to use this point in a few moments, but first let's go ahead and do what? I need to find a slope because I need to have what? My line has to go through this point and be parallel to x plus y equals 2. Well, x plus y equals 2 produces what? I can turn that into slope-intercept form. Y equals -x plus 2. So, what's the slope of the line x plus y equals 2? It has a slope of -1. So I need, and let's write it out, I need a line through -2, 5 with slope equal -1. -1, there's a slope, here's a point. I think using point slope form would be a good way to do this. So I'm going to write y minus, my y1 is 5, y minus 5 equals what? -1 times x minus a minus 2, x plus 2. Y minus 5 equals -1 x plus 2, that's good. I can write -x plus 2 if I want. That's a legitimate equation. Can I represent in a different way? So there's my point slope form. Could I represent this in standard form if I wanted to? Sure. Y plus x equals 2 plus 5. Y plus x, or x plus y, whichever way you write it, is equal to 7. Could I write it in slope-intercept form? Sure, solve just for y. So SI, slope-intercept form, y equals -x plus 2 plus 5, y equals -x plus 7. So again, work ourselves through, same process. We can get there in a lot of different ways, all 3 valid equations. So let's do a little bit more. Find the equation of a line that passes through -1, 1 and is perpendicular to the line through -1, 1 and 2, 2. I need to work with this line first to build the line that they want. I need to figure out who's perpendicular, what's the slope of this line that goes through -1, 1 and 2, 2. Well, let's find the slope. Change in y over change in x. My change in y, I was at 1, I went to 2, so 2 minus 1. And what's my x coordinate done? It's changed from, it was -1, now it became 2. Okay, change in x is 2 minus -1. The slope of this line is 1/3. My line needs to be what? My line must be perpendicular. There's a perpendicular symbol to that. So it must have a slope equals -3, negative reciprocal. So I want equation of a line through -1, 1 with slope equal -3. And let's do the same thing we did before. I'm just going to write one equation this go around. I'm just going to go to point slope form. Here's my point, negative 1, 1. I'm going to have y minus 1 equals negative 3 times what? X plus 1. So there is a point slope form, line with a slope of negative 3 that goes through the point what? Negative 1, positive 1. Remember the way that format works for this particular equation. Find the equation of a line that passes through 2, 2 and is perpendicular to y equals 4. Well, this is an interesting type of problem. So let's do just a little bit of work and let's go ahead and put 2, 2 out here. There's the point that I'm interested in. I need an equation of a line that goes through this point and is perpendicular to y equals 4. All right, well, sorry for my camera shake there, my apologies. I hope you agree that I just knocked my camera over again, but if I want to keep my camera straight, I just drew the line y equals 4. It's a horizontal line. What do I know? To be perpendicular to that, I better be what kind of line? A vertical line. By the way, that vertical line doesn't have any slope, but it has to go through this point. So here we go. Did I draw a line that went through 2, 2 and is perpendicular to y equals 4? I sure did. I drew a vertical line. And if you remember a few things, a horizontal line always has an equation y equals something. A vertical line always has the equation x equals a number. And we know this point is 2, 2. It must be touching, this line has to be going through where the x-coordinate is equal to 2. What's the equation of that line? That equation is nothing more than x equals 2. So we'll work through the last example in one more second. I'm just going to put a quick break in the video, and then we'll pick up. One more problem to work through. And we're going to just kind of read through this piece. There's a parabola here that you see drawn, negative x squared minus 4x. Here, talk about a secant line. Well, that's an average rate of change line that we talk a little bit, but I just want us to focus for the moment just on this line that's gone across. I'm not too worried about that actual parabola graph. I'm more concerned just with these 2 points. And we've been told that there's a line that touches 2 points on this parabola. And that line connects the point at negative 3, 3 with the point at negative 1, negative 5. And you can see that line drawn, and I've highlighted this line as well. They're looking for a line parallel to this that touches the point negative 1, 3, which happens to be right there. So our parallel line should be what? Kind of like this. That's going to be the structure. It should be exactly parallel to the line that's going through here, my 2 blue points. I'll even highlight this line in blue just for the purpose of the visual. What do I know? The line that I need to build has to have the same slope. What's the slope of this blue line? Well, what do I know? I was at negative 3, 3, and I wound up at 1, negative 5. What was my change in y over my change in x? Well, I wound up at negative 5 minus 3, and what was I? 1 minus 3. That's negative 8 over 4. The slope of that line is negative 2. So I hope you can see that point. Let me just move my camera over here for a moment, give you a little bit of shade. So that line has a slope equal negative 2. And so now at this stage, what am I left trying to do? I'm trying to do nothing more than say, what's the slope of a line, equation of the line, I'll move my hand in a moment after I finish writing, with slope equal negative 2 through, what's our point? Negative 1, 3. And again, we're going to stay with our point slope form because that's worked so well for us in most of the other pieces that we work with. What am I going to say? Y minus y1, y minus 3 equals, there's my slope, negative 2, x minus 1, x plus 1. So y minus 3 equals negative 2, x plus 1. There's a great point slope form. If I want to, again, let's just do one more piece just to kind of wrap this up. Y minus 3 equals negative 2x minus 2. Now let's just go ahead slope-intercept form for a change. y equals negative 2x minus 2 plus 3, y equal negative 2x plus 1. So there's a good slope-intercept form representation for the equation of this line that would be parallel to the blue line and goes to the point negative 1, 3. So this is the bottom line with section 2.5. Just be familiar working with different forms of lines. Point slope form can definitely be your friend. It's a very nice way to work through a number of these types of problems. Remember characteristics of slopes of parallel lines. Parallel lines have the same slopes. And remember, perpendicular lines, take those two slopes of the perpendicular lines, multiply them together, you will always get negative 1.